What is that, math peeps? It's Mr. here with lovely little Emily down here with her broom. Um, this is the last edition of the SBAC prep, so thanks for making it through if you made it all the way through. We're going to just go over the last few questions of the review that I found. Just make sure that, again, if you want to take advantage of some extra credit here, that you're watching through the video and taking as many notes as you need in order to be successful here. So let's take a look at the problems and let's keep on going until we finish. Let's go.
Let's hear it. Let it go. Let it go. Can't
Hold it back anymore. Let it go. Let it go. Put it back inside the door. Problem number 26 here requires us to understand two different things that we can make from these maps. So these two maps show the same area on two different scales. Columbus is not on map A, it says. So first thing I'm going to do is I'm going to make sure Columbus shows up somewhere there so that we have a point of reference for Columbus. So looking at the one below here, I think Columbus would be somewhere over here, and there's our new Columbus. Map B does not have a scale written in, and that's a problem because if we really want to figure out some real distances here, we're going to need a scale. So it says Riverside and Gladville are 6.8 centimeters apart on map A. So Riverside and Gladville create a line, as I'm drawing here, and it's 6.8 centimeters. Riverside and Gladville are 3.4 centimeters apart on the second map. So this is 3.4 centimeters here. It gives us the last piece of information that we can draw in is that Gladville and Columbus are 1.8 centimeters apart on map B. So this is 1.8 centimeters. Now what we can see here is what we're trying to find is we're trying to find this distance between Gladville and Columbus on the original map. So I'm going to mark it with an X because I don't know what that is. Now here's what we need to be able to do. Now what we need to be able to do is set up a series of ratios that compares these two distances to each other. So what I'm going to compare in green here is I'm going to compare the 6.8 on my big map to the same side that it correlates to in map B, that's 3.4. So what I've just created is I've created a ratio. Now what it should be also equal to using the same ratio is a similar big side, in this case it's my missing side that I'm looking for, over the 1.8 that it should compare to on the other side. Now here's where a calculator needs to come into play, because if I want to solve for x, I got to do a couple of things. So to get x by itself, since it's being divided by that 1.8, I got to multiply by 1.8 on this side. If I do that, the 1.8's cancel, and I'm left with x all by itself, which is exactly what I want. Now, if we remember correctly, whatever we do to one side of the equation, I gotta do to the other. So here's where you gotta make sure you use your calculator. So once I use my calculator here, so doing a little bit of quick calculations here on my handy dandy calculator, first thing I would do is do 6.8 divided by 3.4. So on my calculator here, I do 6.8 divided by 3.4, and that gives me 2. So now I have 1.8 times 2 in my calculator here. So again, 1.8 times 2 gives me 3.6. So what I see here is that in the big scheme of things, in the big triangle here, or in the big map, sorry, I know that this is 3.6 centimeters. Now, the cool thing about finding this piece of information is that I can now translate it to my scale in this top map here. So for every centimeter, I know it's 40 miles. So all I'm going to do is I'm going to multiply 3.6 times the 40 miles that I know it represents. And in reality, 3.6 times 40 is going to give me 144 miles, which would be my final answer here. So here is the steps that I used to solve. First thing that I needed to do was compare the two ratios together. Second thing I did was I solved for x, and using a calculator, I translated it to an actual distance using what I knew. Number 27 is a great problem in combining two different ideas that we've covered this year. It says Johnny uses a wheelbarrow to move planting soil to a delivery truck. The volume of planting soil that fits in the wheelbarrow measures 2 feet by 3 feet by 1.5 feet. The delivery truck measures 11 feet by 8 feet by 6 feet tall. Johnny puts planting soil in the delivery truck until it's 70% full. It asks us what the minimum number of times Johnny needs to use a wheelbarrow until the truck is 70% full. Now the first thing that I need to find is the volume of the entire delivery truck. Now since it gives us three measurements, my volume is nothing more than just multiplying these three numbers together, 11 times 8 times 6. Now again, if they give you access to a calculator, I highly recommend that you use it. If you feel comfortable long multiplying here, 11 times 8 times 6 is going to give me 528. So I have 528 as the total volume of that particular delivery truck. Now remember, what we're trying to find is just 70% of that. So if I have 528 and I want to find 70% of it, I multiply it by 0.70. Again, using a calculator here, once I multiply 528 by 0.70 here, I get about 369.6. Now this is not my answer. What I need to find is how many of the wheelbarrows I need in order to fill that amount. So the second volume I'm going to find in green here is going to be the volume of the wheelbarrow itself. So the volume of the wheelbarrow here is going to be 2 times 3 times 1.5. Now once I do this multiplication, again using a calculator, what I'm going to get is 9. So with this information, I can figure out how many wheelbarrows I need to fit into that 70% of the delivery truck. And that is carried out by nothing more, nothing less than just a division problem. So I take 369.6 and divide it by the 9 here, and I should get my final answer using a calculator here of approximately 42 different wheelbarrows. So again, this is a type of problem that you have to follow multiple steps. Please just make sure you're keeping in mind the steps that you need to carry out and follow it all the way through until you answer the correct question here. Next problem gives us a graph of a line. It says this graph shows a proportional relationship between the number of gallons of gasoline G and the total cost of gasoline C. Find the constant of proportionality, R, using the value of R. Enter the equation in the form of C of R that represents the relationship between the number of gallons used. So here's what we're given. We're given this handy dandy equation, which represents C is equal to R times G. And what we're looking for first is we're looking for this value of R. Now plain and simple, that value of R is how much this line increases in step to step. A good way to be able to find this is taking one point from our line and plugging in what we know. So if I choose this point on our line, I see that it represents the point 3, 10. Now what we need to remember is which of these variables 3 and 10 represent. So it tells us in the problem that that C and G is the total cost and the gallons. So what we can see is that the gallons is on my x-axis, so 3 represents my gallons, so that is G, and 10 represents the cost. So plugging in this one point, here is what I would get. I'd get 10 is equal to R times 3. Now if I wanted to solve for R, all I'd need to do was divide both sides by 3, and what I can get is my ratio. So R is equal to, 3's cancel, R is equal to 10 over 3. Now I can't reduce that fraction, so that's as good as it's going to get. Now one thing that it's asking us to do is make sure that once we find R, we rewrite it in the form of the equation. So all I'm going to do is I'm going to take my original equation and I'm going to rewrite it with that brand new R value plugged in. And this is my function of proportionality. Number 29 gives us a ratio problem. It says when playing basketball, Jan makes 4 out of every 10 shots she makes. So first thing I'm going to do is rewrite this as a ratio, so 4 out of 10. It says to select all the statements that describe Jan's situation. So 4 out of 10, first thing I'm going to do is I'm going to reduce this fraction because I know that that's exactly what they probably want me to do. So 4 over 10 reduces to 2 out of 5. So the first statement says the ratio of the number of shots Jan makes to the number of shots she takes is 2 to 5. Hey, guess what? We just found one of our correct answers. Now remember when it says all, there could be multiple correct answers here, so let's keep on looking. The ratio of the number of shots Jan makes to the number of shots she does not make is 2 to 3. So I got to think about this. In purple here, what I'm going to write is not the ratio of makes, which is 4 out of 10. The ratio of misses would be 6 out of 10. Which translates when I reduce to 3 out of 5. So delete. So 3 out of 5. Now what we can see is that this ratio is not 2 to 3. This ratio is actually 3 to 5 for the misses. So this is not a correct statement. The equation 4x equals 10y shows a relationship between x, the number of shots she makes, and y, the number of shots she takes. That is definitely going to be true because it's the same ratio that we're using. So we see 4 and 10 there. The equation 6x equals 4x shows the numbers between x, the number she makes, and z, the number of shots she does not make. Here is where we need to make sure that we understand what we are uncovering here. So if she makes 4 shots, which we found up above, she can definitely miss 6 shots. That is our ratio of makes to misses. And the last one is also a valuable option for correctness here. So number 29 requires you to make sure that you answer all the correct options, and this is nothing more, nothing less than setting up a ratio. Problem number 30 here requires you to, again, set up a bunch of different rates here. So the first rate that we see is Mary is walking at a rate of 3 miles per hour. So I'm going to write down that rate, 3 miles per 1 hour. So the first rate is Mary's walking rate. The second one says Jerry starts jogging at a rate of 4 miles per hour after Mary has been walking for 15 minutes. So Jerry, in red here, is walking at a rate of 4 miles per 1 hour. Third point says Jerry jogs 2 miles as Mary continues walking. They both stop at the same time. It says enter the total distance in miles that Mary walks around the track. So first piece of information is that we're given is that Mary has been walking for 15 minutes already. So how long does Mary walk in 15 minutes? So if we think about this, 15 minutes is a quarter of an hour. So if I wanted to figure out how much she was able to walk in a quarter of an hour, all I need to do was divide 3 by that quarter, which is 4. So she walks 0.75 miles in that 15 minutes. Now with that being said, that's not all she walks. The next thing says that Jerry jogs 2 miles as Mary continues walking. So if Jerry runs 2 miles, that means that he's been running, using his ratio, about half of an hour. So he runs at about 0.5 hours for 2 miles. So just using that ratio, that's the way that I was able to work backwards. So if he runs 4 miles in 1 hour, in a half hour, he has to run 2 miles. So if Mary was walking for another additional half hour, what I would add to that 0.75 miles is whatever half of that 3 miles would be. So I'd take 3 miles, and divide it by 2, and I get about 1.5 miles. So in total, in this entire time interval, she walks a total of 1.5 miles plus 0.75 miles. So either using a calculator or just adding it up in using some mental math here, what I should get is I should get 2.35 miles. So again, this is another related rates problem, and we have to make sure that we're keeping those rates straight in order to make sure that we're able to add up the correct mileage here. Another rate problem here. Marcus has a pool that can hold a maximum of 4,500 gallons of water. Now the pool already contains 1,500 gallons of water. Marcus begins to add more water at the rate of 30 gallons per minute. It says enter an inequality that shows the number of minutes Marcus can continue to add water to the pool without exceeding the maximum number of gallons. So here is where we need to make sure that we are understanding what the question is asking us to do. Now instead of solving for m, we need to come up with an inequality here. Now what we know we cannot exceed is that 4,500 gallons that pool has. So whatever we find, it's got to be either less than or equal to that amount because we can't go over that amount. Now if the pool already contains 1,500 gallons, I know that's an initial value that is already in the pool. Now what we are adding to it is we're adding the gallons of water at a rate per minute here. So 30 gallons per minute is just 30 m. So what I have here is my rate, in which I've got my initial value, the thing that I already started with, and the rate that I'm filling the pool. And what it tells me is that I cannot go over the amount the pool can hold. So this right here is my inequality that I can construct that represents this specific scenario. Number 32 is an intimidation problem. So it says values for variables a, b, and c are graphed on the number line shown. It says to use the graph to evaluate the expressions in the table. Select one column for each row. So here's what you need to do first. Make sure you're able to understand what numbers these are. So b or a down here is at -2, b is 2, and c is at 1, 2, 3, 4. So now that I have values for these things, all I got to do is plug them in. So -2 minus b, or a minus b, is the same thing as -2 minus 2. So -2 minus 2 gives me -4. And now which category does -4 fit into? It is definitely less than 0. Next one, I have a plus b. So again, I have -2, but in this case, I'm not subtracting, I'm adding. So I have -2 plus 2. In this case, this is 0. Guess what? It's equal to 0. Next one, I have b minus c. So I have 2 minus a -2. Remember your rules for double negatives. So a negative and a negative gives me a positive here. So 2 plus 2 gives me a +4, which is greater than 1. Next up, we have c minus a. So again, we've got 4 here is c minus a -2, which is a. Negative and a negative give me a positive here, and 4 plus 2 gives me 6. So that is greater than 0. Last one we need to verify is -2a. So that is a plus my c value, which is 4. -2 plus 4 gives me a grand total of 2, which is also greater than 0. So the hardest part about this particular problem is making sure that you're able to understand what these numbers are on the number line and plugging them into their values for the expressions. All right, so that's all, folks. So thanks for making it all the way through. Again, all I can really ask you is just try your best on this test and just show them what you know. So just do the best that you can. It by no means is the easiest test in the world. So if you struggle, just keep on going and try your best on it. Emily, come here. Come here. Oh, she ran away. Well, Emily says good luck, and I say good luck as well. So thanks for tuning in, and hopefully I can post more videos before the end of the year. So peace out. Thanks again.